Good evening. Today we will solve some problems on vertical surface as well as inclined surface. So a question for closing the entrance to dry rock is of trapezoidal form 16 meter wide at the top and 12 meter wide at the bottom and 8 meter height. Find the total pressure on the caisson if the water on the outside is 1 meter below the top level of the caisson and lock is empty. Now see, this is important one. You have to understand this problem. So it is given 1 meter below the top of this. Now we have this as 16 meter, and we have in this fashion. If you calculate area of this trapezoidal, then we have calculated it one half summation of parallel side into height. But actually it is 1 meter below. So we are going to be in this fashion. So we have this is 1 meter below this. So we have total height of this 8 meter. Therefore, if we will calculate this height, which is at 1 meter below, then we will get this as 15.5 meters. Because we have this as given 12 meter. And therefore, area we have to consider that is 1 half 15.5 plus 12 into 8. And then this comes 96.25. Similarly, centroid I have calculated of this. So that I can say as h bar. And this will be 15.5 plus 2 into 12 upon 15.12 into 7 because we have this height which we have that is water. This is 7 meter. And then we will get F is equal to rho g h a h bar, and from this we will get F 3165000 Newton, that is 3165 kilonewton, and Ig for your trapezoidal. So we have Ig as a square plus 4ab plus b square. And then we have this as A and we have this as B. And therefore we have A square plus 4AB plus B square upon 36 into 15.5 plus 12. And then we can find H bar, and H bar we will get it as Ig upon AH bar plus H bar. And then Ig we have 390.890. So we have 899. We have calculated over here. So this is Ig value 390.899. Divided by A 96.25 into H bar 3.352, and we will get H bar equal to 4.56 meter. So we have this will be my pressure and this will be my center of pressure. Then we have a sliding gate 2 meter wide and 1.5 meter deep, lies in a vertical plane and has a coefficient of friction of 0.2 between itself and guide. If the gate have weighs 1 ton, find vertical force required to raise the gate if its upper edge is at a depth of 4 meter from free water surface. So we have actually this gate at 4 meter. So if we have this as water level, then we have this gate that is 2 meter wide and 1.5 meter deep. And then we have friction, coefficient of friction. So here we have actually coefficient of friction over here, that is given mu is 0.2. So whatever pressure will act, we will get vertical reaction to this, which we have to consider as mu into F. And then weight itself. So we have this as 1, and second we have that is weight. So this total we will say weight will act downward, and therefore we have this force will act, frictional force, it will go up, so frictional force will come down, and therefore total we require that is force due to friction and due to weight, and therefore W plus mu F, that will give us total force required to lift this gate. So we have F rho g A h bar 1009.813 into 4.75, because we have 4 meter, this will be top of this, and 0.75 will be center of this. And then we have force required to raise this. I already mentioned mu F plus W gate. So W gate we have given that as if the gate weighs 1 ton, find the vertical force. So we have zero point 0.2 into 139 plus 9806.65. This will be Newton, 1 ton in terms of Newton. Because we have 1 ton, that is equal to 1000 kg, and 1000 into 9.81. So exact value we have 9806.65 Newton. Then we have a tank contains water up to height of 1 meter above the base. An immiscible liquid of specific gravity 0.8 is filled on the top of water up to 1.5 meter height. Calculate the total pressure on one side of the tank and position of center of pressure. So we are going to divide it into two parts. One, we have, if I will draw the diagram over here. So we have this diagram in this fashion. We have first this as your oil of specific gravity 0.8 till this portion, and below this we have water. So below this water, and here we have oil. So this is 1.5 meter, and this is 1 meter. Now we can have this triangle. So my say P1 will be 26487. How we will get it? So now we can have gamma into H. So we have gamma 9810, and we have value of H, that is 1.5. Gamma we have 9810 into 0.8. 0.8 into 9810, because we have specific gravity as 0.8 into 1.5. So we will get 11772. Then we have P1, that is 1 half gamma into H. So 11772 into 1.5, and into width of this. Width we have, that is 3 meters. And from this we will get P1 26487, which will act at 1 meter. That is, this will be 2h by 3. So h we have 1.5 meter. So this is 1.5 meter, and then we will get it as 26487 at 1 meter from top. Then we have second, that is this portion. So this will we act as it is. So we have, this will be rectangle. So P2 portion we have 11772 into 1 into 3. So this 11772 into 1 into, we have 3 meter wide, and then we will get P2 35316. Then we have this as a triangle. Then 9810 gamma into H. H is 1 meter, and then we have this will act, that is 1 half gamma H into 1, and then we will get this force, that is equal to 14715, because we have to multiply it by again 3, which is width of this. So we have these three forces, P1, P2, P3, which are acting at centroid of this, and then total pressure we will get it as 76518 Newton. Now if we have to find out H bar of this, then we have summation P H bar upon summation P, and then we are taking moment about top, we are calculating H bar from top. So 26487 into 1, then P3 we have 35316 into this distance 2, because this is 1.5 and it will act at distance 0.5 meters. Because it is rectangle, it will act at center, so 2 meters. And then 14715 into 2.17 divided by total 765518, and we will get 1.69 meter from top. So 1.69 meter from top. Then we will have next a rectangular tank 4 meter long and 1.5 meter wide, contains water up to height of 2 meter. Calculate the force due to water pressure on the base of tank. So directly you have to find base of tank. We have seen pressure at base of tank. We have gamma A into H bar. Now H bar here we will get it as 2 meter. Here our force will act. Then gamma we have 9810, and area of this tank is given 4 into 1.5. So we have gamma GAH bar 117720 Newton, and this force will act at the base, which is 2 meter from water surface. Then we have rectangular plane surface 1 meter wide and 3 meter deep, lies in a water tank such a way that its plane makes an angle of 30 degree with free surface of water. Determine the total pressure and position of center of pressure. So we know we have given like this. This is given 2 meter. We have to calculate H bar here. So now you can see this. If we will plot the diagram, so we will make a different color. So we have this will be, we are interested to find this value. So we have given this as 1.5 meter because the centroid of this, and we have this angle that is going to be 30 degrees because this angle is given 30 degrees. So we have 30 degrees. So we have 2 meter plus 1.5 sine 30, and that will gives me value of h bar. So area we have 3 into 1. H bar we have seen 1.5 sine 30, 2.75 meter, and then f we can find on this, and we will get value of f that is equal to rho g a h bar, that is 1000 into 9.813 into 2.75, and from this we will get value of f. Now ig, we have ig sine, formula for h star ig sine square theta upon h bar, already we have derived this. If we will go to theory part of this, and from this we will get value of bd cube by 12 into sine square 30 upon 3, we have area, and 2.75 we have h bar, and from this we will get 2.818 meter as h star, or center of pressure of this water pressure. Then we have circular plate, 3 meter diameter. Now we are in the same fashion again. We are in the same way. If we will draw horizontal from this, and then if we will plot this, so we have this diameter that is given as 3 meters. So this again 1.5, and then again we have 1.7, but here this angle is given 60. So 1.5760. So area pi by 4 3 square, h bar 2 plus 1.5 sine 60, 3.3 meter. We have this value of h bar. Now, if we will go to F, then we are going to get this F 229,395.08 Newton. H star, we have Ig sine square theta upon H bar plus H bar. And that value we will get it as 3.428 meter.